Troy.
He's not even here.
I know, because he knew he was going to have to listen to him. And he'd rather listen to you guys than third hour.
Just Troy wants to listen to us and not third hour.
Okay, 7-1. Oh, come and get it. I don't know. Gave Trent a test, must have your name on it. Oh, here you go.
Thank you.
Where's this? Okay. All right. This whole chapter is about hypothesis testing. Just like the last chapter was all about confidence intervals, where we did confidence intervals for big samples, small samples, proportions, variance standard deviation. Once we get past 7-1, which is kind of all of the foundation, we're not actually going to do hypothesis testing here. Once we get to 7-2, it's going to be hypothesis testing for big samples, then hypothesis testing small samples, proportions, variance and standard deviation. So it's kind of a parallel chapter to what we just got done doing. So anyway, what's hypothesis testing? Hypothesis testing is when you use sample statistics to test a claim. Like a battery manufacturer might say, oh, the mean life of all of our batteries is 500 hours. So you believe them, maybe you don't believe them. How can you determine if that person's telling you the truth? You do a hypothesis test, where you take a sample of their batteries, run some lifespans on it, do some statistics, and then at the end of your statistics you can say, okay, you're telling the truth or you're lying. That's what hypothesis testing is. Somebody makes a claim, you test it to see if they're telling the truth or not. And there's a lot of steps to the process, and that's what we talk about today, all the steps. So the first thing you're going to be doing, kind of going to Roman numeral today because it's a lot of just parts. The first thing you're going to be doing is stating a pair of claims. Not claims, state a pair of hypotheses. One hypothesis is going to be the claim that's being made. One hypothesis is the claim. The second hypothesis is the opposite of the claim. Okay, so then you're going to have two hypotheses there. One of them is going to be true, one of them is going to be false, because you'll see why in a minute. One hypothesis is called the null hypothesis. Does anybody know what null means? Elliot?
Like non-relevant or something like that? Like
Nope.
void?
You're hearing null and void? In this case, null means, think math, none. It means none. So the abbreviation for this is H sub 0. Okay? So the H sub 0 is called your null, and you'll know the null hypothesis because in it you will either have, it will contain an equal to, a less than or equal to, or a greater than or equal to. So if your hypothesis has one of those three signs in it, it's the null hypothesis. And then the one hypothesis is called the alternative hypothesis. And we're going to abbreviate this one H sub A, the ha. Okay, like I said, they're going to be opposites of each other. So, if the null hypothesis has an equal to, what's the opposite of equal to? Not equal to. What's the opposite of less than or equal to?
Greater than.
Just greater than.
And then it's just less than.
And then it's just less than. So the null will always have part of an equal to it. Equal, less than or equal, greater than or equal, that's your null. Alright, so what we're going to do now, for our first example, is given the claim, write a pair of hypotheses. So write a pair of hypotheses. So the first claim that's being made is being made by that battery company. And their claim is that the mean battery life is 500 hours. So we're going to identify our first hypothesis as the claim. And all of these claims are about population. They're claiming this about all of their batteries. So when they say the mean, what's our symbol for population mean? Mu. So they're claiming that the mu is 500 hours. What math sign do we have for is? Equals 500. So is their claim the null hypothesis or the alternative? Why is it the null? Because it's got the equal to. Equal to goes with the null. So we label that the null. So I said write a pair of hypotheses. So either this is true or the alternative one is true. What's the alternative? Not equal to. Do you agree that one of those two statements has to be true?
Yes.
Yeah. So that's what hypothesis testing does. We're going to decide which one of these two things is true. We're not actually going to do that until we actually get to 7.2, but for now, we're just getting the foundation. That's it. We wrote the pair of hypotheses, done. That's our first step in all hypothesis testing. Being able to rewrite the claim and identify it as the null or alternative. Okay. Still on, same thing, write a pair of hypotheses. This time the claim is that the proportion, and this was a radio station making the claim about the proportion of the local listening audience. So the proportion of the listening audience is over 39%. So maybe they would give this statistic to their local advertisers. You know, over 39% of the people in this area listen to our radio station, so maybe you should advertise with us. That's who would probably use a statistic like that. But anyway, our goal is to test this claim. Okay, this time the claim is about a proportion, not a mean. What's our symbol for population proportion? P hat is sample proportion, just P. Over 39%? Greater than? Making the claim which hypothesis? HA, the ha. You agree that that's the ha?
Yeah.
Okay, what's the corresponding? less than or equal to is the null. More.
Basically, whatever one we could.
Well, that's one thing I've done, Elliot. I got to talk for the whole hour. Think I'm going to do this for an entire hour?
Yeah.
No.
That'd be nice.
I'm not. I'm going to do one more though.
Really.
Claim is that the variance of the lifespan is no more than (3.5) hours squared. Yep. Terrible dot. Okay, so what's the claim about? First of all, what's our symbol? Hold on, variance. Population variance symbol. Sigma squared. That's our population variance. No more than, less than or equal to 3.5. Which hypothesis is this? Null. More fun to say the whole. It will get more fun. Okay, so if that's the whole, what's the ha? Greater than 3.5. Claim whole. It's coming. All right, so there's your first, going to be, when we get to the hypothesis testing, first thing you have to do is write the pair of hypotheses. All right, big idea number 2. Big idea number 2 today. We want to talk about types of error that happen in hypothesis testing.
How many big things we need to know?
I think we've got 3 or 4. Can't remember. Types of error in hypothesis testing. Okay, first off, when you actually start the hypothesis testing, we always test the whole. That's a good idea.
I do just like saying that.
I do. It makes everybody laugh. Is the claim always the whole? No. We had one where the claim was the ha, 2 where the claim was the whole. So we're not testing the claim. We're always going to test this null hypothesis to see whether that's true or not. So we always test the whole. And after the test is done, there's only 2 possible outcomes, 2 decisions that will be made. 2 possible outcomes. So when you're done with the test, you're going to say one of these 2 things. You're going to say, I reject the whole. It's a good option. What's the other side of the coin? No, never, never, never accept the whole.
Reject the ha.
No, we only test the whole.
Accept the ha.
No. No. So you can reject the whole.
You can claim the whole.
No, we're going to... Everybody wants to accept because you think, if I don't reject, then I accept. Kind of makes sense, but you fail to reject the whole. It is not the same thing. Fail to reject the whole does not mean accept the whole. All that means is, boy, the whole's still in play. I haven't been able to eliminate the whole. So both hypotheses are still in play.
Like, the whole comes, the whole leaves, the whole, like...
So, if we reject the null, it's gone. If I fail to reject the null's still there, but so is the alternative. They're both still in play. Much more fun to say whole, Paige.
She's like, I need eggs for the whole, I need milk for the whole.
Okay, so the whole big thing here was with the types of error. So when you make your conclusion, reject the null, or fail to reject the null, maybe you made a mistake. Maybe you had a bad sample. Maybe you've made some bad statistical calculations. Who knows? That's when an error happens. And how are you going to know if you made an error? You're never going to know unless somebody repeats the study and says you're wrong. So when that happens, you get one of two types of error. Type 1 error.
Yeah, you do.
Type 1 error occurs
When they leave.
when the null is rejected.
Just say home.
Paige doesn't want me to.
Funnier.
I know it is.
When the
Hey,
whole.
stop being a fun sucker.
Paige, you're a fun sucker. Paige is a fun sucker. I can't take it. I have to sing.
Yes. Everybody stops giggling after about a day or two. Type 2 error. I don't even know if I wrote all that. Occurs when the whole is rejected when it was actually true. A type 2 error occurs when you fail to reject the whole when it actually was false. So there's your type 1 and type 2. When you make your conclusion, reject the whole or fail to reject the whole, and it was a wrong conclusion, they're called type 1 and type 2. So when you get to these problems in the homework, they're pretty much just definitions. But I'm going to take you through one.
What section is longer, 1 or 2?
One's a lot longer. This section, oh, you mean part day 1 and day 2? Or what are you talking?
Well, today, like, what section?
We're doing 2 sections today.
We're doing, it would have been a 7-1 day 1 and a 7-1 day 2. So it's all of 7-1. Yeah.
Oh, I get it, because you're not going to be here tomorrow.
Correct.
Okay.
So then you'll get the
Where are you going to be?
going down to take softball team. Don't you?
Taking the whole team?
2 of them. Caravan. There we go.
Having fun, Paige is fun. I know, I'm just kidding, Paige. You're a big blaster.
Go smack them, Paige. Oh, missed my B. Okay, a parachute assembly company makes a claim that the main parachute failure rate
What is that? Ascending?
assembly
Assembly.
the main parachute failure rate what does it mean to have parachute failure rate? What is it? What does it mean for a parachute to fail? It doesn't open.
Oh, that's
Pull the ripcord,
It doesn't necessarily die, that's like
nothing. You got nothing on your main parachute. Okay. Main, yep, you got your second chute. Main parachute failure rate is not more than 1%. Well, just think if it was 1%. That's 1 in 100 parachutes that are not going to
I didn't
open.
go to that.
Okay, that's not a good. But this is not more than 1%.
I'm going to bring 2 parachutes.
Okay, So, as a consumer watch group, do you want to make sure that their claim is true? We're going to test their claim to see, are they really true or not true? So, well, we're not actually doing the test today, but what I want you to do with this problem is describe a type 1 and type 2 error. So when you get to the homework tomorrow when it says describe a type 1 and type 2 error, it pretty much is just definitions. But you kind of have to go in context to what the null hypothesis is. So again, it always starts with those pair of hypotheses so that you know which one's the null. So the claim being made is that the main parachute failure rate, what's another word for rate so I can get my symbol correct? Or if you look at the percentage here. Proportion. This is about a proportion. What percentage of the parachutes fail? So this is about P. What's not more than? Less than or equal to. It's not over 1%, but it is less than or equal to 1%. Which makes the claim whole. So then the ha would be that the main parachute rate is actually over 1%. Okay. So the whole point of example 2 is to describe what a type 1 error would look like and describe what a type 2 error would look like. So you'd go through the whole test. A type 1 error would mean, and like I said, they're pretty much just definitions. A type 1 error occurs when the hoe is rejected. So a type 1 error would mean I rejected the P is less than or equal to 1% when it actually was true. So who did I harm by making this error happen? Did I harm the company or did I harm the public? The company. I said, no, they're lying to you. I'm rejecting this.
Why wouldn't it be both, though?
But it actually was true.
Because it's not hurting the...
Because what I'm telling the public is that their main parachute rate is greater than 1%, so like, whew, we'll stay away from there. That's helping me out. But I was wrong. I made an error. So I hurt the company. All the people stayed away from the company.
Because their claim was actually true.
Because their claim was actually true. It was smaller than 1%, so that would be the company I'd want to go to with that small failure rate. But I said, oh no, this is wrong. So I harmed the company. I'd probably get sued by the company.
Too much of this.
Yep. A type 2, again, it's just definition. You don't have to do that little description that I did at the end there, but a type 2 occurs when I fail to reject the hoe. So I failed to reject that the proportion is less than or equal to 1% when it actually was false. So who did I hurt more on this one, the company or the public? Definitely the public. Okay, so type 1 and type 2 errors, all you've got to do is figure out what the hoe is, and you just kind of plug it into the definitions and you're good to go. Did that. Okay, next big idea, are we on number 3? Is level of significance. Our symbol for level of significance is this lowercase alpha, also known as Jesus fish.
I'm very religious, so
That was funny.
I take offense to that.
What? That is, isn't
You
it?
can drop the JC word every day in English. What? The JC word.
Jesus sees, right? Hunter does, and I'm.
It gives you your maximum probability of making a type 1 error. It determines, because on a type 1 error we reject the hoe, it determines the size of the rejection region. Okay, and then the last thing in here is that the ha determines where the rejection region is at. And that's what we're going to do next. Is located. Yeah, you guys definitely get through the notes a lot quicker than third hour. Are we good? So continuing on. So we've got 3 different options for the ha. So then we have 3 different rejection regions. So the first one, what signs can be in the ha? There's 3 of them.
Not equal.
Not equal to?
Greater than or equal to.
Nope.
No, greater than, less than.
Greater than and just less than. Let's go with greater than. If the ha has a greater than in it, this is going to be called a right-tailed test.
Wait, are these just like key points for this?
Yep, we're still under that, yes. So if your ha has a greater than, we're going to call this a right-tail test, which means our rejection region is going to be in the right tail of the normal curve. So you'll have your normal curves. Your rejection region, which we're going to shade in, is going to be in the right tail because of the greater than. So when we go through and do the math, the shaded region is where we are going to reject the hoe, because we always test the hoe. If we land in the white part, we're going to fail to reject the hoe. And what's going to separate these, shaded from the unshaded, is going to be a critical value. And if it's a big sample, it's going to be a z-score. Small sample is going to be a t-score. Proportion is going to be a z. Standard deviation and variance is going to be a chi. So we're going to be doing the same things we did in the last chapter with z's, t's, and chi's. So we just call this a critical value. C for critical. And then the amount that's shaded, though, is equal to your alpha. And that'll always be given to you. Quite a bit. It's 2 days worth, Paige. Okay, you told me ha could have a less than. What do you think we're going to call this test? Left tail test. Because the rejection region is going to be in the left tail. So less than, reject to the left.
Can we have like a break after this?
No.
You said we're faster.
Way faster.
Yeah, so give us a break.
Well, no, because then I can figure out the homework. So the size of it will be alpha. It could, and the common ones are 1%, 5%, and 10%, but that doesn't matter. So again, the white part's going to be the fail to reject the hoe, and the shaded is going to be reject the hoe. Never, never accept the hoe. And then our last option for the ha, not equal to. So we had left-tailed test, right-tailed test. Any guesses?
Middle.
Two-tailed.
It's too fast. No.
You're going to have a little bit of rejection in the left and a little bit in the right. So how much do you think is going to be shaded in each little piece compared to alpha? So it's always going to be equal to whatever alpha they give me. Half of alpha. So half of the alpha is going to be in the left, half of the alpha is going to be in the right. And it's still going to be fail to reject in the middle.
Wait, this is called alpha?
Yes.
Oh. We already learned that, didn't we?
Yes. Okay, so number 3, determine what tail test you will do here. Okay, the claim being made is that the mean height is 64 inches. I don't care what it's about. So, and our goal is to determine what tail test. All your answers come from that pair of hypotheses, so it's just good practice to rewrite the claim. And then identify the claim as, is it the hoe or is it the ha? If it's the ha, I can answer my question that I asked. If it's not, I gotta find it. So, mean height. So what's my symbol in my claim? Mu. Is 64.
Equal.
So the claim is the hoe. That doesn't help me determine what tail test I'm doing. The ha does. So what's the ha have?
Not equal.
Not equal. So what tail test are we doing? Two-tailed test. Done. That's very easy.
No, I don't get it.
Oh, I know, yeah.
What part? The claims or the two-tailed?
Why is it two-tailed?
Because if I have the ha has a not equal to, it's always two-tailed. Okay.
It goes with the graph.
I was just distracted before whole word.
What?
You said horse.
I said hoe or.
Four.
Oh, I didn't even catch that. Hoe or ha. No, I didn't say the whole word. Ah, no, that was not intentional at all either. Ho or ha. Oh yes, I could see it now. Ho or ha. Hor, right there. Got it. That was bad. I'll try to avoid that. I'll have to say ha or ho. Then I'll avoid that. Will take care of that. Okay, proportion is less than 5%. Proportion's the symbol. Proportion symbol is P. Just P for population, p hat for sample, less than 5%. Ha or ho. This is the ha. Do I know what tail test I'm doing?
Yeah.
Left tail. Yeah, you need a book. Yep. Yep.
Why didn't you switch it and come to the...
Because to answer this question, what tail test, all I needed was the ha, so I could get that question right off the bat with because I knew the ha. What tail test is determined? I could write the whole. But when I'm still asking what tail test am I doing, I look at the ha to determine it.
Okay, so you look at like the first one and the...
Well, it's the ha. I have to look at the ha to decide what tail test.
Okay.
So here, my claim was the ho, so I still had to write the ha.
Okay, makes sense.
Here it was the ha, so I got it. I know what the ha is, like left tail. Okay, we're at the last big idea. You can handle it, Paige?
No.
You got like 5 more minutes in your hand?
No.
Shake it out.
So
You can do it, Paige. Stay with me.
15 minutes, do whatever we want.
Yep, I'll come up with an assignment here for tomorrow. Tomorrow. But some people aren't going to be here. So,
White girl problem. Like legit white girl problem.
oh yeah, this is big idea number 4. Interpret your decision.
How much room do we need at lunch?
Quite a bit. Half a page. Well, here is where you want to say something about the claim that was being made. Say something about the claim. Because remember, we're always testing the whole, and I always make my decision based on the whole, but the claim could be the whole or the ha. So I want to use the last 2 claims that we just had, and I'm going to make a little chart. Okay. So in the last example, one claim was that the mean equaled 64. That was the ho. And then the ha was not equal to 64. Then in the second part B, the claim was that the p is less than 0.05. That was the ha. Greater than or equal to 0.05 is the ho. Okay. So it's kind of just like a little 2-part flow chart. If the claim starts out as the ho, and remember, we always test the ho. Because when we finish our hypothesis test, we're going to say one of 2 things. Reject the ho, fail to reject the ho, because I'm either going to land in the unshaded or the shaded. So reject the ho, or fail to reject the ho. Nope, this is going to be it.
You should put up that thing.
Well, I'm going to do the other one over here.
Okay.
I mean, the second tree is going to go over here. All right, get that down. Remember, down here I want to say something about the claim. The whole point was, are they telling me the truth or not? What am I going to say about their claim? So, if their claim was the ho, in this case, the claim is the ho, and I reject the ho, what do I say about their claim then? Are they telling me the truth? When I say my mean, what was that, lifespan, or no, the mean height is 64 inches, and I reject that, I'm rejecting the ho. What does it mean to reject it? Throw it out. Rejecting it is throwing it out. So if I'm throwing out the ho, what am I throwing out with it? What they're saying. That was what they said.
So claim is false?
Claim is false. They're lying. Claim is false. Well, if I fail to reject the whole, that doesn't mean I accept it. Never, never say accept. No, it's not saying it's true either. What I'm saying is I can't eliminate this. So at this point, both things are still in play. I can't say for sure which one is true.
So it's not true or false.
It's not true or false. So what we say is there is not enough evidence to say the claim is false. No. Okay, so what I want you to, and I do have a poster of this, I don't know if you remember it from back in geometry, but if your claim is the whole, your results always have the word false in them. Over here, you're going to see those, our interpretations are going to be different. If the claim is the ha, we still test the whole. Every time we run through a hypothesis test, we're testing the whole. And when we're done with our test, we're going to say reject the whole or fail to reject the whole.
Wait, why are we still saying whole?
Always test the whole. We never just automatically test the claim, we always test the whole. That's just the way the process works. But now I want to say something about the claim. So, in this case, I'm still going to test the whole to see whether this is true or not. If I reject this whole, that's gone. What can I say about the claim?
Claim is true.
Their claim is true. Because when I reject a hypothesis, I throw it out. It's not true. So the whole is not true, which means, oh, then this one has to be, and that is the claim. Claim is true. And now if I fail to reject the whole, that means the whole is still in play, the ha is still in play, they're both there to say the claim is true. There is not, but I can't say it's false either, enough evidence to say the claim is true. So pick up on the fact that if it starts out as a ha, you're finishing with two things about true.
We're done.
Oh, the shortcut, not shortcut. The abbreviation for this. Not enough evidence to say the claim is false. NEEF. There's one little thing. Because you're going to get tired of writing that out all the time, so we abbreviate it right off the bat. Over here, not enough evidence to say the claim is true, so we're going to call it neat. That's neat. All right, homework. Let me figure it out here. So for those that need it. 1. It won't. It's yeah. No. This is for tomorrow because some people aren't here tomorrow either. So if you're not here tomorrow, you can write it down. If you are here tomorrow, you can just wait for whoever's sitting here to give you the assignment.
I'm gonna do it tonight.
Let's see. Interpreting a decision.
Oh my god.
I'm ready to take because I'm broke. So he like doesn't even deny it.
But your hair is awesome. I know.
And remember, that's a 2-day assignment. So, but you should have no problems getting it all done in class tomorrow. No problems.
I'll just have Dave do it.
Okay.